We have seen in the ideal gas law how pressure, volume, and temperature are related, and there is this little n here, which I said is the number of moles, which it tells us about the number of molecules in say the oxygen gas. Now, but that is okay. That's fine. But how in the world do we know what n is? So that's what I'm going to explain now. The idea of the mole is as I think I've mentioned earlier, one mole means, right, it's actually equal to 6.022 times 10 to the power of 23. All right, and it usually refers to is usually used for, if you like, counting, if counting is actually possible in such a case, for counting particles, like any particles really, molecules, atoms, electrons, protons, usually atomic or subatomic particles. Now, just to because this is such a huge number and definitely not something that we use in everyday life, not mole as in the animal or mole as in the undercover agents, or mole as the spots on a face, but mole as in this huge number. Let's think a little bit about how we use this number and how we can actually find out its value for a particular gas. So first of all, to get used to using this number, now I like to think that a mole, all right, a mole is really not so the idea of the mole and using a mole is not really so different from, say, a pair, right? A pair or a dozen. Okay, a pair or a dozen, right? If I say I have one pair of socks, how many socks do I have? Well, I have two socks if I have one pair of socks. So if I say a pair, I think two. And okay, it can be socks, it can be other things. Okay, if I have a dozen, I think 12. If I have a dozen eggs, I know I have 12 eggs. So what if I have a mole of oxygen, a mole of oxygen gas? What does this mean? So a mole of oxygen gas means I have 6.022 times 10 to the power of 23 oxygen molecules. And this is exactly what 1 mole of oxygen gas means. Okay, so I hope that makes it easier. So if I have, say, another gas like nitrogen gas, then I would say nitrogen molecules. Carbon dioxide gas would be carbon dioxide molecules. But what if it's a mixture like air? Air has nitrogen and oxygen. Well, unfortunately for mixtures, it doesn't really make so much sense to say 1 mole of air, okay, because it's a mixture. because if you say 1 mole of air, you don't actually know how many oxygen and nitrogen atoms, molecules there are. Although you can say it might refer to the total, but it's not always clear if you don't actually make say anything more than 1 mole of air. It's a bit like saying I have a dozen of eggs and socks. How many eggs and socks do I have? So the idea of a mole of gas, for example, or substance, is usually more direct to refer to use it for a pure substance with only one type of atoms or molecules. Okay, but now comes the next question. Okay, what is N? How do I tell what N is? I don't know, like if I have, say, oxygen, okay, how would I think of the amount of oxygen? Well, the familiar measure to me, but I know that it's not very useful if I say the volume of the oxygen. Okay, if I say 1 meter cubed or 1 centimeter cube of oxygen, I know that because volume can be compressed, I might have more or less molecules in 1 unit of volume. But I can say mass, right? I can specify the mass, like maybe 0.1 gram, 0.1 gram of oxygen. Okay, so that's quite definite, quite clear. If I have 0.1 gram of oxygen, there must be that number of molecules, right? I'm specifying the mass. But if I have 0.1 gram of oxygen, what is N? I've been talking about how N is the number of moles, and then how 1 mole is this number of oxygen. Okay, fine. But if I have 0.1 gram of oxygen, so how many moles of oxygen molecules do I have? Now I'm going to explain the short answer, the fast way of getting the answer to that, and then in the next session I shall explain more about the reasons and ideas behind this. Okay, in order to answer this question about how many moles of oxygen we have in 0.1 gram of oxygen, let me just write down the question. 0.1 gram of oxygen gas is equal to how many moles? That's the question. Okay. Now the answer is this. In order to find this answer, I need to know something called the relative molecular mass of O2, of the oxygen molecule. Okay. And again, I'll explain more about how to actually find out what this mass is in the next video. But for now, I'm just going to take this as given. So suppose that you are given the relative molecular mass of O2 is actually 32. So to answer this question, all I need is to take the mass in grams, take 0.1 gram, and divide it by this number for the relative molecular mass. That's it. That's the number of moles. That's the N that I would use. Right? That is the N, little n that I would use in the ideal gas law.